Welcome back, class. In this final class of the first term, we'll take a closer look at how GR and IN scores predict rider performance in next summer's rally. At the end of class, I'll talk a bit about what you can expect to learn in part 2 of the course next term. Today we begin with this question. How do an apple's odds of finishing at the top 20% next summer vary depending on her GR score percentile? Last time we saw that the M value at the 80th percentile of the distribution was 35.3. That's the value of M that divides the top 20% from the bottom 80%. So today, we're going to calculate the probability that apples with GR scores at different percentiles will ride more than 35.3 miles. Let's begin with the apple with a GR score at the 10th percentile. Last time, we saw that this GR score is 3. We don't know this apple's GE score, so we'll use 5.6, which is the average GE score for last summer's riders. The regression equation tells us that M hat for an apple with these GR and GE scores is 19.4. Applying the 12% rule, we find that this apple's SE is 2.3. And when we ask HackMath to tell us the area to the right of 35.3 in this apple's probability distribution, as you can see, 35.3 is quite literally off the chart. There is no area to the right of 35.3, which means it's next to impossible for an apple with these scores to finish in the top 20% of riders next summer. We now repeat the analysis for apples with GR scores at the 25th, 50th, 75th, and 90th percentiles, and here are the results. With GR at the 10th, 25th, and 50th percentiles, there is virtually no chance that the apple will finish in the top 20% next summer. With GR at the 90th percentile, he has a 37% chance of finishing in the top 20%. When we repeat the analysis for an orange rider, we find that his odds of finishing in the top 20% are significantly better than the apples at all GR score percentiles. And when we repeat the analysis for a grape, the IN score advantage becomes even more apparent. A grape has much better odds of finishing in the top 20% than an orange at all GR percentiles. However, unlike GE and IN, for which a rider's parents and community are mainly responsible, a rider's GR score depends only on how hard he applies himself. An apple at the 50th GR percentile has better odds than an orange at the 25th GR percentile, and an apple at the 90th GR percentile has better odds than an orange at the 50th percentile and a grape at the 25th percentile. This demonstrates how greater effort can compensate for the IN score disadvantage. We can also look at things the other way around. What are the odds that a rider will finish in the bottom 20% given his GR and IN scores? Here are the results, and the story they tell is similar. At all GR score percentiles, the orange has a clear advantage over the apple, and the grape has a clear advantage over the orange. There's hardly any chance that an orange or a grape with a GR score at the 50th percentile or higher will finish in the bottom 20%, but an apple with a GR score at the 25th percentile or lower has virtually no chance of finishing above the bottom 20%. But again, hard work can compensate. The apple with GR at the 75th percentile has better odds than the grape with GR at the 25th. And the apple at the 90th has better odds than the grape at the 50th. Next term, we'll shift our focus from what I would call little data, using a database of only 30 riders, to what I would call big data, using a database of all Americans born between 1978 and 1983, numbering more than 20 million. Instead of using our data science tools to explain performance in last summer's bike rally, we'll use them to explain the incomes of these children 35 years later, between 2013 and 2018. Instead of GR, GE, and IN, our explanatory variables will include the child's parents' income, property values and crime rates in the neighborhoods where the child grew up, and the level of formal education she reached. The database was compiled by a group of professors and students at Harvard University's Opportunity Insights project, drawing on Internal Revenue Service and Census Bureau data. For each child, the database includes observations of the variables I've just mentioned, and many more. Here's an example of what we can learn from this database. The x-axis of this XY plot shows 100 percentiles of average parent household income in 1978 to 83. The y-axis shows the percentage of children of parents in each parent income percentile whose incomes at age 35 were in the top 20% of the child income distribution. For example, this point represents the children of parents at the 60th percentile of the parent income distribution. On the y-axis, we read that 20% of these children had incomes in the top 20% of the child income distribution at age 35. This point represents children of parents at the 92nd parent income percentile and shows that 40% of these children had incomes in the top 20%, twice as many as the children of parents at the 60th income percentile. When we measure the correlation between child and parent income for these 20 million child-parent pairs, we find that it is 0.34. That means that a simple regression of child income versus parent income will have an R-squared of 0.34 squared, which is 0.12, which means that parent income by itself explains 12% of the variation in child income. Next term, we will look at other variables that help explain child income, and we'll estimate a regression equation that includes the most important ones as explanatory variables. That equation will have a higher R-squared value. But how well will that equation predict incomes at age 35 for kids born after 1983? The predictions for kids born soon after 1983 should be pretty accurate because their age is close to the target age group. This is also true because the Opportunity Insights database includes the entire population of children in the target age group. So unlike our 30-rider sample from last summer's rally, there's no uncertainty as to whether the Opportunity Insights database is representative of the population. But how representative is it of children born a generation later in 2008? Come back next term to find out.